Thank you, Jess. So, welcome. I'm your host, Liam Gumley. It's funny that Steve Jobs was mentioned a couple times in the meeting already. Well, right about now, I feel like Steve Jobs when he would say, and by the way, there's one more thing. So, I want to talk about one more thing that we do here at CIMSS and SCC in conjunction with our partners at NOAA, and in fact with partners around the world. And that is to provide sounder data, infrared and microwave sounder data, as part of the World Meteorological Organization DBNet project to NWP centres around the world. And just so I get off on the right foot, we are just part of the DBNet group. EUMETSAT, put your hand up, Nick. EUMETSAT is another big dog in the DBNet group. Thank you. Météo France, JMA, KMA, the Bureau of Meteorology in Australia, INPI in Brazil, CMA. I'm going to forget somebody at some point, and I apologise if I do, but it's a worldwide community of DB data providers who work very, very hard indeed to provide low latency. And by low latency, I mean within 30 minutes of the start of a DB overpass to provide that sounder data to NWP centres around the world. So I'll talk about our contribution to that project. So I want to recognise Bruce Flynn. Bruce, raise your hand, he calls himself the data wrangler, but he does much, much more than that. Software engineer and good guy to hang out with as well. And funding from Mitch Goldberg and from JPSS Program Office. Officially it's a NOAA project, so I can't really make any promises that NOAA will do this or NOAA will do that as part of DBNet. It has to be cleared with Mitch, but Mitch gives me pretty free rein, fortunately. So, just before I delve into the details of the DBNet, I just wanted to review some of the activities related to LEO direct broadcast that we undertake at CIMSS. And you've heard some of this already during the last 3 days. So we own and operate 5 X and L band antennas, and those are located one in Madison, one in Miami, one in Mayagüez, Puerto Rico, Honolulu, and another one in Guam. So if you're going to have to go to remote antenna sites and work on them, those are not bad places to visit, especially in the middle of winter. We also develop and distribute this thing called CSPP, which I'm sure you've heard about. We develop and we in fact still distribute the IMAP software for processing data from a suite of LEO satellites. And furthermore, we receive DB data and we create images and products that are then forwarded to NWS forecast officers in CONUS and the Pacific region, and to a number of other clients, including government, education, and commercial. And I think Kathy will talk later today about some of the broad, indeed the hidden users of CSPP that maybe wouldn't be so obvious. So, in terms of what we do as part of DBNet, we have this system that we call the DBRTN, the Direct Broadcast Real-Time Network. So, to summarize, I said here on my slide NOAA, and by that I mean CIMSS, because CIMSS is a NOAA cooperative institute. We receive direct broadcast data from JPSS, MEDOP, NOAA, and the Aqua satellites at level 0 from antennas that we own and operate, and from a number of partner antenna sites, 22 sites in total. And we process that data centrally to level 1B, and we create buffer products. And this is sounder data. I'm hardly going to talk about imager data at all in this presentation. And the goal of DBNet, so our goal for NOAA DBRTN is to deliver that infrared and microwave sounder data to NWP centres, or at least make it available to them within 30 minutes with respect to the start of the DB overpass. And keep in mind that a DB overpass averages about 10 minutes. It can be as short as maybe 7 minutes and as long as 13 minutes. So we provide ATMS, CrIS, IASI, ATOVs, and AIRS sounder data in a specific DBNet buffer format, and those buffer data sets are delivered to NCEP. That actually goes directly via an FTP push to NCEP, but they're also disseminated to NWP centers around the world via the Global Telecommunication System, the GTS. So for example, ECMWF, Met Office, DWD, Media France, Bureau of Meteorology, etc. They're all able to get the data from DBNet. And unfortunately, I didn't put in a slide about the impact of DBNet data, but ECMWF in the last 4 or 5 years has actually published a paper or two about the impact of low latency sounder data in their forecast system compared to stored mission data. So, DB data, latency of maybe 30 minutes versus 2 or 3 hours from stored mission data. And it turns out that the DB data has significantly more value because it's more timely, especially in the ECMWF continuous data assimilation system that they've implemented now in operations. So I mentioned that DBNet is facilitated by the WMO. This isn't just some University of Wisconsin project that we dreamed up. It's an official effort that's facilitated and guided by WMO. In fact, there's a WMO DBNet coordination group that meets, I think, pretty much every year, where there's representatives from EUMETSAT, CMA, KMA, JMA, all the contributing operators, where we talk about what's happening in the network, what's working well, what's not working well, which stations are up, which ones are down, and improvements to the network. Nick Coyne from EUMETSAT mentioned how we've been testing the WIS 2.0 dissemination mechanism as a potential follow-on to GTS, or even a replacement for GTS at some point. So anyway, this is just a screenshot from the WMO DBNet webpage. Russ Healy inspired me to throw a QR code on there so you can link to it very quickly. So this does operate under the auspices of the WMO. So here's the family portrait of our antennas that are out in the field. These are all orbital systems antennas. So orbital system guys, raise your hands. There they are. They're all X-band, L-band capable. 4 out of the 5 are 2.4 meter diameter, except for the one that's in Guam, which is a 3 meter diameter antenna. And we really need to thank the hosting organizations at these remote sites, because these are not located on UW land. In Honolulu, it's at Honolulu Community College. At Miami, it's at AOML. Mayaguez, it's at the University of Puerto Rico, Mayaguez. And at Guam, it's at the National Weather Service Forecast Office. So we were very fortunate to get all those organizations to agree to host these antennas. And in return, we provide them local products, and we've even been to each one of those sites and presented a multi-day training workshop. So I mentioned that there's 5 antennas that we operate. There's 2, air quotes, NOAA antennas that are located at Fairbanks and Monterey. And I mean those are antennas that were either funded by NOAA or are actually owned by NOAA. And Jen, raise your hand. Jen is in charge of one of those antennas up at Fairbanks, and we're very fortunate to get real-time feeds from those antennas in the United States. But we also get data from 15 other partner antennas around the world on every continent, including Antarctica, because JMA, Toshi mentioned in his talk a day or two ago about their station in Showa. So we're fortunate to get ATMS data from that station. But there's a number of other organizations around the world that have agreed to supply their data to us at no cost so that it can be processed and delivered to DBNet. So we thank those organizations profusely. And I should also mention ATSC. Adam, raise your hand. They provide data from their station at Kwajalein. Okay, so this is our current coverage map. Well, actually, let me just skip just back a second. So on the WMO website, you can see in bottom left, they have coverage maps showing the different DBNet services. So there's an ATOV service, ATMS, CrIS, YASI, and VAS from the FY3 sounders. Those plots are probably a little bit out of date. I think they're November 2020-ish. And that's from all the DBNet providers. This is the coverage that we are now providing from the network of stations that are part of the DBRTN subset of DBNet. And by the way, full disclosure, there's hardly a day when actually all of these antennas are working perfectly. There's always one antenna that's having some problem or another. Like for example, right now today, Santiago is offline, and there's a bit of debate about whether or not they'll come back online. I'm always hopeful, but you know, things happen. And as you can imagine, far out in the field at places like Easter Island or Ascension Island, you know, they can be challenging places to operate a system and get data back to a central facility. But we keep pretty close tabs on the operation of all these stations every day. By the way, these, they're not really circles or the eggs. Those are relative to the antenna location. That's where the satellite would be at 5 degrees elevation above the horizon, where you can receive signal from it. So this is just the laundry list. I don't expect anybody to read it or study it, but those are the 22 sites that are part of our network right now. Oh, I forgot to mention Environment Canada. Matt's up the back. So they send us some SNPP data from their antenna in Edmonton. I'm trying to think if there's anybody else in the room that sends us data. Well, anyway, if you are, and I haven't thanked you enough already, thank you again. So, these were some of the recent changes since 2020, stations that we added to our network. Louder in New Zealand, although they're actually bringing up some upgrades on their stations so that some of that capability will actually transfer back to NOAA. Santiago was up for a little while on L-band. It was providing some really useful ATOVs and YASI data, but they're currently down. We're trying to figure out if they can come back up. Dhahran in Saudi Arabia, they have an X-L-band system that has been providing data pretty reliably, but they had some recent internal network changes that basically took their system off the internet. So it's down for a while until the person in charge comes back from summer vacation, to be honest. At Dhaka in Bangladesh, that system is up and running really well. That's at University of Dhaka. That's been running since early 2020. And then most recently, there's a new station that's operated by CIMSS, formerly known as CLS, in Lima, Peru, that's providing data. And by the way, MEDOP AHRPT ended on November 15 of last year. So in terms of processing software, you know, we do the processing centrally here at UW, which means we can make sure that the same version, the same lookup tables, the same calibration, same geolocation is used for every data set, no matter where it came from in the world. That's a little bit different than the traditional DBNet model where the processing is all done on-site. But we decided early on we were going to do the processing centrally. So using CSPP SDR, Metopizer, AAPP, OpsLRS, and our conversions to buffer are all done via the AAPP scripts. So the data that we produce from the infrared microwave sounders is monitored very closely by the NWP SAF, which is funded by UMETSAT, to make sure that they're consistent with the global product. Now, they're not identical. And Matthew from Media France had an interesting presentation on this topic this morning. But they should be close enough that it makes no difference to an NWP end user. So the radiances have to agree to within some tolerance. The geolocation has to agree. So at this page or this site that's provided by NWPSAF, they monitor that very closely for every pass from every DBNet site. So I'll just show you a couple of screenshots from that NWPSAF site. So on the left, they're comparing the brightness temperatures from NOAA 20 ATMS from the Ascension Island site, which is operated by CrIS, compared to the global NOAA 20 data from NOAA, and showing that they're agreeing to within fractions of a Kelvin, thousandths of a Kelvin. And then on the right-hand side, they're showing comparisons of CrIS level 1 data, brightness temperatures from channel 342 of CrIS, from Chonburi in Thailand versus the corresponding global product, and showing that the agreement is very good indeed. And furthermore, NWPSAF does have automated alerts that let you know if either the data has gone missing or it's exceeding the thresholds they've established for the match to the global data. We monitor the latency of the data sets very closely. In fact, Bruce designed a system that captures all this information for every pass that we process, and it accumulates monthly statistics. So this is the statistics for CrIS at Dhaka in Bangladesh, and what we're seeing is latency of the data set arriving on the site where NOAA can pick it up to put it onto GTS. I probably forgot to mention that NOAA NCEP, or NWS NCEP, they're the group that puts the data onto GTS, because we can't do that ourselves. So these statistics are relative to the start of the overpass. So for CrIS data from November 2021 at Dhaka, average latency of about 20 minutes. And in fact, the red trace is the cumulative availability, and you can see that it reaches 100% at around about 30 minutes. So even with ingesting data from that remote site, we're doing good in terms of timeliness. Same story for IASI data for Chonburi, although you can see there's a couple of cases where passes take a little bit longer to show up, but the majority of the average latency is less than 20 minutes. And then even for Easter Island, which has a very limited bandwidth back to the mainland, we only get ATMS and ATOVs from Easter Island. But nevertheless, in most cases, about probably the 95% level, we can meet the 30-minute latency threshold. Back in 2020, with some encouragement from Mitch and others, we added Aqua Air's data to our DBNet suite. And I think as of right now, we're the only partner in WMO DBNet that's providing Air's data. And that actually came in useful for a while when I think there was a NOAA distribution capability for AIRS that went offline for a number of reasons. So then folks like the Met Office that wanted to assimilate it, they could get it from DBNet instead. Second last slide. So there are some other applications that we have. I mentioned that for the antennas that we operate, we do have a local processing system on site at each one that does convert image data to products, and those images are typically converted to AWIPS format for the local National Weather Service Forecast Office. We do collect Argos data collection system data at a number of our antenna sites, and we deliver that to CLS/CNIS in real time. And furthermore, at several of our antenna sites, we receive AMSA2 data from GCOM-W1, courtesy of JAXA, and provide those products to local offices. So just to summarize, we're continuing to receive data from 22 antenna sites. Of 13 of the 22 support NOAA, JPSS, MEDOP, and the POSE satellites. Everything's disseminated on GTS via NCEP, although we're experimenting with WIS 2.0. AIRS data was added in 2020, and planning is underway right now to support JPSS2 and MEDOP SG. That's it. Thank you.
Do we have questions for Liam? Yes, Alejandro.
How can a DB station be added to the DBNet? What locally we have to do? I ask you because also 2 years ago we were trying to do it.
Yes, we talked about it when we came to Mexico. We talked about it when we came to Mexico City in early 2020. The only thing that we need a partner antenna site to do is to set up an atomic push of their level 0 data to our server here at Wisconsin. And that can be by either FTP or SFTP. And by atomic means that the file doesn't appear on our site until it's fully transferred. And we can tell you how to do that. So other than that, that's it. No other requirement.